Hello everyone and welcome to my first PIC and Assembly Language Lecture Series Part 1. In this episode, we will first talk about simulation basics. However, before we can simulate, we need some software requirements. Among it is the MPLabX IDE. As noted, it is a software program, a multi-platform program, and it is developed by the Microchip company, the makers of PIC microcontrollers, and they provide single integrated environment to develop code for embedded microcontrollers. Next, we need to download 3 of these compilers, which are for PIC 18, 16, and for the 32-bit PIC CPUs. So in order to download, let me just click this in my presentation. As you can see, this will open a window here. You will just need to click this one and you are immediately brought here. Depending on your platform of choice, Linux, Windows, and Mac. For me, in this tutorial, we'll be using the MPLabX IDE here, which is 367 MB. Last updated on February 21, 2014, and these 3 compilers here. Once you have finished downloaded these installers, you need to install them. However, I'm not gonna show it in this video. Once you install them, you can open them, and from the start menu, you can open the IDE. There we go. Let's maximize this. First, in order to show you the workflow, let us create a very simple program that adds a number to a certain register. In the later parts of the series, we'll be discussing about registers and assembly language stuff. In this episode, I am only going to show you the simulation workflow so that you can be familiar of what is going to happen in future videos. First, we create a new project and we just choose standalone project. We choose the family. For our videos, we'll be using an 8-bit MCU from the mid-range set, and we'll be using PIC 16 F877A. This is widely available in the market. And we'll be using simulator. We'll be using this one. And finally, for your project location of choice, I will name this vid01 for first series, and I will store it here. And let's name this exercise 01. Just click finish. So what we've done here is that we have defined the project and what PIC microcontroller is involved in our project and the location of our project. Let us add a source file. We'll just call it an empty file, and let's call it main.asm. In the folder, just leave it as it is, so it will go here under the x01.x folder inside the vid01 directory. Just click finish, and do note the name is .asm so that the assembler can immediately identify it as an assembly language file. For our code, in order to put a comment, you just use this syntax. As you can see, it automatically turns into green indicating that the text that follows after that is a comment. Let us call this exercise 01, and the description of the project, let us call this program adds a number to the working register. So let's make this capital so that you know that there is a working register. And let's name of the author. Let's name this Bang Kali, and the date so that you can identify when you last modified this file. Let's close this header and let's proceed to the code. In most programs, assembly language programs, you want to define where in the memory your program starts. So let's add that here. Origin is set to 0. And then let's add a comment. Use the org directive to force program start at reset vector. Then we start our program. First, we need to clear the working directory, I mean the working register. Then we name the label of this line. Let's call this loop, and then we add this number 8 to the working directory. Let's make sure this is tabbed properly. Okay, add the number 8 to the W register. Then we go to loop. That means after we have added, we go back to add. So this continues adding. And then we end our program. I think this is kinda self-explanatory. As you can see earlier, this main.asm was bold. That means there was a modification and it was not saved. Once you save it, it is no longer bold. If I add a space here, it becomes bold again. So you need to save to make sure that the modification is saved. That can help you later. So once that is saved, you can then go to this button. Let us begin now in simulating the project. Let us click debug main project. So it has built successful. Let us pause the project so that we can know what line are we on. When I pause the project, we are now at line 13, as you can see here. This line 13, if we go to window, debugging, and we go to SFR, I mean output, PIC memory views, then SFRs, you can see here that the W register already has a content which is 32, and the PCL or the program counter is already 2. As you can see here, this is line 13. Why is it 2? So if we go to disassembly, we can see here the disassembly of our code. At address 0, we have clear W. At address 1, we have add LW, or the add 8 to register W. And then at 0x2, or address 2, we have go to 0x1 or go to clear go to the add part. So as you can see from here, there are actually only three addresses being used, from address 0 to address 2. So we are at green in this green part in our disassembly. That is why in the program counter we are at 2. In our main code, where we had lots of comments, these are unnecessary comments, we are at line 13. In order to avoid confusion, you should go to disassembly and observe that you are at this line. As you can see, our comment is included here. This is our comment, and this is the address. It is in address 2. So you can see here that the address in the program counter is 2. Once we step over, we go back to 1 because the command here is go to 1. That is it. So we go back, the program counter is once again set to 1, and if we observe, we step over again, 8 is added to the W register. This is what it is doing. Add 8 to the W register. And once we click next again, we go back to the address 1 and address 2, address 1, and while that is happening, the W register is being incremented by 8. In another window, here in the PIC memory views and program memory, as you can see here, we will close these guys. So this is the actual program memory. This is the disassembly, and this is what's inside the memory. At address 0 is clear W. At address 1, we have this command. You can actually see here that the command is 3E and the value is 08. This is the 08 part, and this is the command. So we can identify immediately that 3E is add LW and 08 is this one. So this is the disassembly. And in here, we can see that the command is 28 and the value is 01 because we are going back to address 01. Essentially, if we step over once again, there is an arrow here that indicates where in the program memory you are currently located. So this is just how simulation works. This is for a very simple program where we add a value of 8 into the working register. So a question we must ask: what happens when our register is having a value that is more than 255? As you know, a register is only 8 bits wide and can only store up to 255 decimal value. So what happens then if we exceed 255? This is an exercise that you will be doing. You must observe what happens if you continue to step over and over again, and until the value of register W exceeds 255. Thank you for watching this first episode of my PIC and assembly language programming series.